Hello! Welcome to Chapter 3, Section 1. We are starting our chapter on probability. So as you know, this class is called Honors Probability and Statistics. So up until now, we've really just been talking about statistics. So we finally get into the probability part of it. And as we go on throughout the year, then we start mixing in the two because they are important together. So as we start the chapter, of course, we always have some vocabulary that we want to define first. That way, as we go throughout the chapter, we are using like common words together and we know what they mean. So the first thing I want to talk about is the probability experiment. So probability experiment, it's just really fancy words to say like rolling a die, flipping a coin, chance processes. The next vocabulary word is an outcome. So basically what happens. The result of something. So the result of a single trial or action. An example, like if I were to roll a die, then an outcome could be like rolling a 3. And sometimes you'll see outcomes written with these squiggly brackets, and it just shows people like, this is an outcome. So then a sample space is the list of all possible outcomes of a chance process. So if I'm rolling a die, all the possible outcomes could be me rolling 1 through 6. So 1 is a possible outcome, 2 is a possible outcome, 3, 4, 5, 6 are all possible outcomes. So mathematically, when we write it out, we use the squiggly brackets and then we can list out all the different outcomes that would be included in a sample space. When we refer to an event is when you deal with one or more outcomes. So it's always a part of the sample space. That's what a subset means. So it could be one thing in a sample space. It could be multiple things in a sample space. So an example would be something like if I were rolling a die, rolling a 3 would be considered an event. Also, rolling an even number would also be considered an event because rolling an even number would consist of rolling 2, 4, or 6, and that's all part of a sample space. So when we look at this mathematically, we usually use capital letters to stand for events. So I could say like event A equals rolling a 3. Event B would be rolling an even number. We could use all the letters, but usually capital ones. Okay, I just want to do a quick example problem so that we can kind of see like how do we use these vocabulary words. So example, a probability experiment consists of tossing a coin and rolling a 6-sided die. Describe the sample space. So if you remember, sample space means it's a list of all the possible outcomes. So since we are tossing a coin and rolling a 6-sided die, then with those two actions, we need to list out all the different combinations of the outcomes that we could get. So when I toss a coin, I can either get heads or tails. There's no other options I could land on. When I roll a 6-sided die, I can land on a 1, a 2, a 3, 4, 5, or 6. But combining the two actions together, when I flip a coin first, I could get heads. But then at the same time, I'm also going to roll the die, so maybe I land on a 1. So I could get heads and then a 1. Or I could flip heads and then land on 2. Or I could flip heads and land on a 3. Or I could flip heads and land on a 4. And so on. So I have all these different outcomes that could potentially happen. So I want to list them all out because I could also land on tails and then land on a 1, tails 2, tails 3, and so on. So when we're dealing with the sample space, if you're just doing one action, then you're just listing out the the outcomes of that one action. If you're doing multiple things, you have to like write down all the combinations of them. So in this sample space, there are 12 total combinations. We can also use this to list it out using a tree diagram. A tree diagram is just a way for us to kind of visualize, kind of like a graph, but not really. It's like more of a picture. And the tree diagrams are nice because you can show things in chronological order. So it's like, oh, if I'm going to flip a coin first, then I want to list out the possibilities for flipping a coin first, which is either heads or tails. So there's 2 outcomes possible when I flip a coin. So I make 2 little like branches in my tree diagram. But then the next thing that I do is roll a die. and when I roll a die, there are 6 outcomes possible. So let's say I landed on heads first, and then if there's 6 outcomes for rolling the die, then I can draw 6 branches in my tree diagram to show that there are 6 options for rolling the die. And then same thing if I had landed on tails the first time, then when I roll the die, I have 6 outcomes again that could happen. So in total, at the very end, I'm going to count up in my tree diagram all the branches at the end, and that'll tell me how many total items I would have in my sample space. Okay, the next vocabulary word is a simple event. So a simple event is just an event that consists of a single outcome. So something like rolling an even number would not be a simple event, because rolling an even number, there are like 3 different ways for you to do this. You can roll a 2, you can roll a 4, you can roll a 6. So that's not a single event. There's 3 events included in that. So that wouldn't be simple. So example, is this a simple event? You roll a 6-sided die. Event B is rolling at least a 4. So remember, at least means like this number or more. So at least a 4 would be 4 or more. When you roll a die, the max number is 6. So when we say at least a 4, this would include 4, 5, and 6. And so that's 3 different numbers. That's 3 different events that this event B would include. So no, this is not a simple event. Okay. So the next thing I want to talk about before we actually get into the probability is something called the fundamental counting principle. So the fundamental counting principle just helps me figure out like how many total outcomes there are. So something like the sample space. But rather than listing out all the possible outcomes, I just want to know the total number. So you're going to find this number by multiplying the number of each category. And so this is the easiest way to do this, is to actually use an example. So I don't know if you know, but Chili's has like a 3 for $10 deal. I'm pretty sure they still have this going on. I don't know with like COVID and everything, but they used to have this 3 for $10 deal, where you get to choose a beverage, an appetizer, and an entree for $10. It's a pretty sweet deal. Back in the day, I went out to lunch with a bunch of math teachers, and like on the front of, I think it was an Applebee's menu, they were saying like for their whatever deal that they had, I don't remember exactly what it was called, they advertised like over 1 million different combinations that you could make or something like that. And we were like, no, we're going to actually figure this out. So all you have to do is figure out like how many different options you have for each like beverage, appetizer, and entree, and then just multiply them all together. That'll tell you the total amount of different options, or the total number of outcomes. So at Chili's, they have 14 beverage options, 8 appetizer options, and 9 entree options. So when you multiply that all together, that'll tell you how many different ways you can order the 3 for $10 deal. So 14 times 8 times 9 is 1,008. So Chili's has like 1,008 options. I think wherever we were at, Applebee's or something, as math teachers do, there were over 1 million, and like we actually proved it correct. And fine, their advertising was good. Another example to use the fundamental counting principle is, I don't know if you've heard of a capsule wardrobe, but I'm pretty sure a capsule wardrobe is like, if you're like very minimalist and you have like a very small wardrobe, like the amount of items in your closet, where everything matches with each other. So like no matter what you pick out of your closet to wear, it'll always create an outfit. So this is like slight goals for me. Actually, I don't know, like, when I saw it on Pinterest, I was like, oh, this is cool, because I like living minimally, because then like you save a lot of money, blah, blah, blah. But then, I don't know, I like color in my life, and yeah. So a capsule wardrobe usually is like very, like, since everything has to match with each other, all your clothes, it's very like one color, or like black and white or something easy to match. So I'm like, I like colors. I don't know. But anyways, so let's say you had a very minimalistic wardrobe of 3 pairs of pants, 5 shirts, tops of some sort, I don't know, and like 2 pairs of shoes. With just those items, you can make 30 different outfits total. that's enough clothes to match to last you for a month with having different outfits every day, which is kind of crazy because 3 times 5 times 2 is 30, and so 30 different outfits with just 10 items. So 3 pairs of pants, 5 tops, 2 pairs of shoes. It's not bad, which is why I'm saying like it's a pretty cheap way to live. However, I don't know about that one. I don't know if I can do it for myself. Okay, now that we know how to find the total number of outcomes for something, this will help us when we start calculating probabilities. So first, let me talk about the different types of probabilities. The first type is what you are most familiar with at this point. Classical or theoretical probability. So this is basically a formula. So the formula looks like this. It's just a fraction. You're going to take the number of desired outcomes, so like whatever you want, whatever you're being asked about, and divide by the total number of outcomes, which we just learned how to find. So this thing in front, P parentheses E, this is just like a shortcut way for us to write the probability of an event E. So if we do some examples, the probability of rolling a 3 on a die, because we want to roll a 3 that is one of the faces on the die, so there's one desired outcome, but then the total number of outcomes is 6 because there are 6 different ways you can roll a die. Cool, so the probability of rolling a 3 is 1/6. Rolling a 7, there are 6 ways to roll a die, but a 7 is none of the faces on the die, so 0 out of 6, which is also just 0, because 0 divided by 6 is 0. Okay, which means if you have a probability of 0, that means it's never going to happen. You're never going to roll a 7 on a die, unless you have a special die that actually has 7s on it. I don't know. And then the probability of rolling a number less than 5. So we're still rolling a die, so 6 total outcomes still. But then a number less than 5, when we say less than, we're not including the 5. So that would be numbers 1, 2, 3, and 4. So there's 4 ways to do this out of the 6. And I know this is a fraction where you can reduce it, but in this class, I don't care. You don't have to reduce. You can leave it as a fraction. If you really want, because you're used to, I know some people are just familiar with probability in terms of percents. You can turn this into a percent. So if you take in your calculator 4 divided by 6, you would get 0.6 repeating, which is like 0.67 if you round it to 2 decimal places. So if you turned it into a percent, it would be like about 67%. So all of these different methods of writing your answer is acceptable to me. 4 over 6, 0.666 or 0.67, whatever, if you round, 67%. I don't care how you give me your answer. All of those are fine. The next type of probability is called empirical or statistical probability. So empirical just means that you looked at data of some sort. So you either gathered data or there was like previous research, whatever. So to find this probability, you're taking the frequency of whatever you want, the desired outcome, and dividing it by the total frequency. So for example, we've got a company conducting a telephone survey, and here's their data. I'm not even going to read through the rest of the problem. Here's the data. We are looking for the probability that the next person surveyed has a positive overall impression of the 2000s. So positive response would be these people here. That's what we are desiring. So that's the number that'll go on top. And then on the bottom is supposed to be the total frequency. So if you add up all the frequencies that they give you, we get this 1504 number, because they already did it for us. So our probability would just be 406 over 1504. So one thing I wanted to talk about relating both the empirical and classical probabilities is that something called the law of large numbers. So the law of large numbers is something like a phenomenon, I guess, related to probability, where as you do some sort of experiment or chance process, the longer you repeat it, so if the more times you do it over and over, the empirical probability, the one that you gather from data of the event, approaches the classical probability, the classical or theoretical probability, which sounds like a lot of fancy words, but basically, if you think about like flipping a coin. So if you flip a coin just like 5 times, just looking at those 5 times the probability of you flipping heads is probably not going to be very close to 1/2, because we know when we normally flip a coin, the probability of landing on heads should be 1 out of 2, or like 50%, because one side of the coin is heads and the other side is tails. But if you do it 5 times, let's say you get 3 heads out of those 5 tries, then your empirical probability would be 3 out of 5, because you've only attempted it that many times. 3 out of 5 is like 60%, so not that close to the 50% at all. You might have even gotten unlucky and just gotten 1 head out of the 5 times, which would put you at 1 out of 5 is 20%, so definitely not close to the 50%. But if you keep flipping more and more times, then the amount of heads that you actually get versus how many times you've actually flipped the coin gets closer and closer to 50%. That's what the law of large numbers is saying. The last type of probability I want to talk about today is subjective probability. And so this is like the most basic, like non-mathematical one, because it's based on your intuition, like your best guess. So if I was like, oh, I feel like it's like a 40% chance of rain today. I'm not a weatherman. I don't know these things, but that's how I feel. And so that's subjective probability. Another example is like sometimes doctors, based on their experience, they might feel that a patient has a 90% chance of a full recovery. So based on how they've seen or how their experiences have been in the past, they're able to make this educated guess about the probability of a full recovery. All right, the last thing I want to talk about for this section is just rules about probabilities. So probabilities, there's a range of probabilities rules. This just means that there's like a smallest number and a biggest number that probabilities could be. So the smallest number a probability could be is 0. And 1 is the biggest probability you could get. So if you're thinking about this in percentages, it's like 0% to 100%. When we're talking about fractions, 0 to 1. When we're talking about decimals, you can have like 0 point something something, but you can't have 1.2 or whatever. So if your event has a probability of 0, that just means that event will never happen. A probability of 0 means that the event will never happen. The opposite side, if you have a probability of 1, that means the event will definitely happen. Okay, and then all the numbers in between, so like 0.9 would be closer to it happening, like 90% chance of rain or something like that. It means you're pretty much going to get rain that day, but slight chance that you might not. And the last thing is complementary events. So complementary just means like not like a compliment, like, oh, look, you look so good today, but like compliment as in they like go with each other. So when I say they go with each other, I really mean like the opposite. So the way we write it is in our mathematical terms, we have P parentheses E with little apostrophe on it. So the apostrophe stands for the complement. Complement meaning the opposite. So basically the same thing as finding the probability of not event E. So the opposite of event E. For example, let's say my event was trying to roll a 3 on a die. So if I put the apostrophe there, that just means the probability of me not rolling a 3. So not rolling a 3 would be me rolling numbers like 1, 2, 4, 5, or 6. And so there's 5 ways to do that out of my 6 ways possible. So the probability of not rolling a 3 would just be 5 over 6. This can also be found by taking 1 and subtracting the probability of me rolling a 3. Because the probability of me rolling a 3 is 1 out of 6, because there's 1 face on the die, 6 total, and so 1 subtracting that is going to give me 5/6. So in other words, the probability of not getting E, or not event E, is the same as 1 minus the probability of E. So that's kind of nice to use. All right, so that's all I got for this section. Thanks for watching. Bye.